Hello, this is a very short recap video just on terminology and specifically on chemical equilibrium. So we just want to have a good understanding of what chemical equilibrium is. When I use that term, what am I talking about? So this is just a short video to help us with that understanding. So we're going to use a color changing mug to help us with constructing a definition of chemical equilibrium. So our color changing mug, perhaps when we bought our color changing mug, it was this beautiful blue-green color, aqua color that we bought it in. And the very first time that I decided to make a cup of coffee in my color changing mug and I added in my hot water, I saw that my color changing mug starts to change color. So suddenly that blue color disappears and we're left with a pink purplish color. Immediately after that, I decide to throw out the coffee out of my mug, and after a few minutes I observed that it's changing back to the blue-green color that it was initially. So this is an interesting concept for us in chemistry, because initially our understanding of chemical reactions would be something along the lines of saying that we have two starting materials that together, when they react, will give us a unique product that has different properties than our starting material. So this is a totally different new product that we have, or chemical that we have. And what we can see here, that this reaction can only happen in one direction. So A plus B needs to combine to give us C. However, in our reaction with our color changing mug, we see a change happening. So if A was our blue color that we had here and C was our product color that we have here, but the difference being that in this reaction, we're able to reverse the change that we're seeing. So the color of our mug can change back to the blue color. And in chemical reactions, for our equation, we would then use a double arrow to illustrate that concept. So a double arrow in a chemical reaction, or in a chemical equation rather, illustrates to us that we have a reversible reaction. Of course, the reversible reaction that we have here is just a structural change in the molecule responsible for the color, but it stays nonetheless a reversible reaction. So this is our first requirement for systems that can establish a chemical equilibrium, is that we should have a reversible reaction. So we have a forward reaction to give us our product, but we can also have the reverse reaction taking place in which our product converts back into the reactants. Now, most chemical reactions, even though it's not observable with the eye, are constantly taking place before us. So we have a constant transformation of A plus B into C, and a constant conversion of C back into A and B, or decomposition. So at some point or another, for chemical equilibrium to occur, the rates of the two reactions that we have here, the forward reaction and the rate of the reverse reaction, will become equal to one another. And that is really the situation in which we have chemical equilibrium. So if we wanted to illustrate that on a plot, we could say that we can plot the rate of our reactions against time. So we can plot our forward reaction and our reverse reaction as two different plots of rate against time. Right. And it is at this point, at this very, very crucial point, where the two rates become equal to one another, that we have established equilibrium. So it's very important to know it is not the concentrations of our reactants and products that are equal to one another. It is in essence the rate of our forward and of our reverse reactions that are equal. So in a nutshell, that's really just the definition of chemical equilibrium. I hope you have a better understanding of exactly what the term means.